We can observe solar eclipses because the moon is about 400 times smaller than the sun, yet it is also about 400 times closer to Earth. As a result, it can completely block the sun's disk. However, in roughly 50 million years, the moon will no longer be able to cause eclipses because its orbit will change. The tallest mountain in the solar system is Olympus Mons on Mars. It is 3 times higher than Mount Everest, the highest peak on Earth above sea level. If you were standing on the summit of Olympus Mons, you might not even realize you were on a mountain, because its gentle slopes are hidden by the curvature of the planet. A full NASA spacesuit costs about $12 million, and roughly 70% of that price goes toward the control unit and the life support backpack. Astronomers have discovered a gigantic cloud of water in space, the largest ever found. Unfortunately, it is extremely far away, about 12 billion light-years from Earth. This cloud contains 140 trillion times more water than all of Earth's oceans combined. The Earth's inner core is comparable in temperature to the surface of the Sun. It consists of a solid alloy of iron and nickel surrounded by extremely hot liquid material. The temperature at the boundary of the core reaches nearly 6,000 degrees Celsius. In 2015, astronauts tasted food grown in space for the first time, a red romaine lettuce that had been cultivated in a special chamber for 15 months. The ability to grow food beyond Earth means that in the future, humans may be able to stay in space longer without relying on massive food supplies in orbit. More than 120 million pieces of space debris are currently orbiting Earth. Sadly, all of them were left behind by humans. These fragments travel at tremendous speeds, around 27,000 kilometers per hour, and it is best not to be in their path. You may have noticed that Earth is not affected by the solar wind. We can thank the planet's iron-nickel core and its rapid rotation for this. They generate a powerful magnetic field that protects us. Once, an astronaut secretly brought a corned beef sandwich into space. When he pulled it out in zero gravity, the sandwich began to fall apart. He had to quickly hide it so that crumbs would not damage the spacecraft's equipment. The age of the solar system is about 4.6 billion years, and figuratively speaking, it is already quite old. Scientists reached this conclusion by studying the oldest materials available for analysis: meteorites. You are probably familiar with methane, a gas produced as a byproduct of natural processes such as volcanic activity and the digestion of animals. Interestingly, methane is also present in Mars's atmosphere, and its concentration continues to increase. This seriously puzzles scientists since the source of the gas remains unknown. Hence the joking question, could there be cows on Mars? Like a giant cosmic lighthouse, a supermassive black hole located 570 million light-years from us flares every 114 days. Recently, astronomers recorded powerful bursts of light coming from this black hole, whose mass is about 20 times greater than that of the black hole at the center of our galaxy, the Milky Way. At present, scientists have only one explanation for what is happening. The black hole is tearing chunks of matter from a star orbiting around it whenever the star gets too close. This discovery is considered extremely unusual, since no one has previously observed black holes behaving in this way. Normally, when a star approaches a black hole, the immense gravity stretches it in a process known as spaghettification. Most of the star's material is then swallowed by the black hole, while the rest is ejected into space in bright, elongated streams. In this case, however, things are different. With each close encounter, the star loses an amount of mass equal to 3 times the mass of Jupiter, the largest planet in the solar system. These moments are when the powerful flares observed by astronomers occur. The flares are so regular and consistent that scientists have been able to predict some of them in advance. In particular, they were observed on September 6 and December 26, 2020. Nebulae are vast clouds of gas and dust in space. In the night sky, they may appear either as bright glowing patches or as dark regions silhouetted against luminous matter. The Red Rectangle Nebula, located in the constellation Monoceros, stands out sharply from others. Straight lines are rare in the universe, yet this nebula, as its name suggests, is made up of distinct lines and angles. Its color is also unusual, a rich orange-red hue. Astronomers believe that its glow does not come from internal activity within dust clouds, but rather from processes occurring at the molecular level. The age of the universe is estimated at about 13.8 billion years, yet the star HD Alpha-Tanzu 283, unofficially nicknamed Methuselah, appears to be more than 14 billion years old. The paradox deepens because this star contains chemical elements typical of second-generation stars, those formed from gas and dust left behind after the explosions of the first stars. This raises an obvious question. How can a star be older than the universe itself? The most likely explanation is an error in the calculations that caused the star's age to be overestimated. Gravity is the force that allows us to stand firmly on Earth's surface. For the same reason, the average person can jump no higher than about 50 centimeters. But what if we lived on other planets, such as Venus or Saturn? Let's explore the challenges we would face. We'll start with Mercury, the planet closest to the Sun. Gravity there is about half as strong as on Earth, so a person could jump roughly 1-2 meters high. However, extreme temperatures make this world incredibly dangerous. On the sunlit side, the surface heats up to about 427 degrees Celsius-like, standing neck-deep in molten lava. At night, temperatures drop to 173 degrees Celsius. On top of that, a single day on Mercury lasts 176 Earth days, so you would have to wait a very long time for day or night to change. Leaving this hostile planet behind, we move on to the even harsher Venus. If it weren't for the thick cloud cover, Earth would be visible from there. These clouds create an intense greenhouse effect and enormous atmospheric pressure. Jumping on Venus, you would rise only about 60 centimeters off the ground, since Venus is similar to Earth in size and mass. It is unbearably hot, and even the rain offers no relief. It is made of sulfuric acid. Skipping Earth, we move directly to its natural satellite, the Moon. Lunar gravity is only about 1/5 of Earth's, so a jump would lift you nearly 2.7 meters off the surface, and you would land again several seconds later. It is remarkable that this rocky body has such a strong influence on Earth's tides. And if you stayed on the Moon for a couple of million years, you would notice that it is slowly drifting away from our planet. The next stop is Mars, also known as the Red Planet. Here, a person could jump about 1.2 meters high. Mars has an atmosphere, but it is much thinner than Earth's. If you stay until evening, you can witness a striking bluish sunset. From here, Olympus Mons is also visible, the tallest mountain in the solar system, nearly 3 times higher than Mount Everest. And yes, it is a gigantic volcano. Now let's head to Phobos, one of Mars's moons. Jumping here is strongly discouraged. Gravity is so weak that you might not return to the surface at all. Phobos is very small, comparable in size to a large asteroid, and it orbits Mars almost 100 times closer than the Moon orbits Earth. Eventually, it is doomed to collide with Mars and break apart. Scientists believe that after this happens, Mars may develop rings similar to those of Saturn. Next, we encounter an unusual object, Ceres, the largest asteroid in the solar system. It is so large that it has been classified as a dwarf planet. Ceres lies between Mars and Jupiter in the main asteroid belt. If you jumped on its surface, you could soar to a height of about 16 meters and then drift slowly back down. Remarkably, Ceres accounts for roughly 1/3 of the total mass of the asteroid belt. Our final stop is Jupiter. Since it is a gas giant, it has no solid surface, so jumping there is physically impossible. Theoretically, in its upper atmospheric layers, you might be able to jump only about 20 centimeters. Jupiter is 10 times larger than Earth and about 300 times more massive, giving it an enormous gravitational pull. In addition, the planet hosts a colossal storm that has been raging for at least 400 years. Although it has weakened over time, even today this storm could swallow Earth whole. Let's travel to Ganymede, Jupiter's largest moon. Its surface is solid, and here you could jump roughly 3 meters high. Although Ganymede is larger than Mercury in size, its mass is much smaller, so gravity there is relatively weak. The moon is covered with a thick layer of ice, and deep inside it lies a liquid metallic core. Thanks to this core, Ganymede is the only moon in the solar system known to have its own magnetic field. The next stop is Saturn, the second largest gas giant. It is slightly smaller than Jupiter, yet it could still fit about 9.5 Earth-sized planets inside it. At the same time, its mass is significantly lower. If Saturn had a solid surface, a person could jump about 40 centimeters, almost the same as on Earth. The planet is famous for its spectacular rings, which are made of ice and dust particles. Because Saturn rotates so rapidly, its shape is noticeably flattened. It has 62 moons, only 5 fewer than Jupiter. Let's take a closer look at one of them. Titan, Saturn's largest moon. Here you could jump to a height of about 3.3 meters. Titan's atmosphere is unusual. It is dense, heavy, and composed mainly of nitrogen, giving the surface a permanently hazy appearance. The moon itself is almost entirely made of ice, with a rocky layer beneath it, while water is believed to exist deeper down, closer to the core. Another remarkable feature of Titan is its cryovolcanoes that erupt ice rather than lava. To reach Saturn's atmosphere, one would have to pass through its magnificent rings. They are composed of fragments of comets, asteroids, and shattered moons, making such a journey extremely dangerous. In addition, Earth would have to avoid collisions with Saturn's many moons. There are 53 of them. But let's imagine the impossible. If all collisions were avoided and Earth became Saturn's 54th moon, the gas giant's immense gravity would trigger catastrophic tectonic shifts. The planet's surface would begin to tear apart, and eventually nothing would remain of Earth. Not exactly an optimistic outcome. Uranus and Neptune belong to the category of ice giants. They are roughly the same size, larger than Earth, but smaller than Saturn and Jupiter. Both planets are covered in ice and display beautiful greenish-gray hues. If one of them replaced the moon, the consequences would be similar, so let's choose at random Neptune. Imagine looking up one day and seeing Neptune in Earth's sky. It is 14 times larger than the moon and would appear as a gigantic bright blue sphere, visible both day and night. It would seem about 15 times larger than the Sun, and solar eclipses would occur regularly. Each time the Sun disappeared behind Neptune, our planet would be plunged into total darkness for more than an hour and a half. Neptune's mass is 17 times greater than Earth's, and its gravitational pull is far stronger. As a result, our planet would become one of its moons, orbiting Neptune at a distance slightly greater than that of its largest moon, Triton. In that case, there would be a risk of collision with this object. Even if we assume we were lucky enough to avoid that, we would still face serious problems. Tides on Earth would become 1,000 times stronger than those caused by the moon. Neptune's gravity would not tear the planet apart, but it would significantly heat it. Seismic activity would gradually increase, triggering frequent earthquakes and volcanic eruptions. And quite possibly, we would lose the internet. Now for a thought experiment. Imagine 2 parallel horizontal lines and connect them in 2 ways, with a straight vertical line and with a diagonal line. Which one is shorter? Of course, the vertical line. It is the simplest and fastest way to connect the lower and upper lines, just as the most efficient way to reach orbit is along a direct path. The lower line represents Earth's surface. Our planet is a complex mixture of many different substances, combined into an enormous mass, nearly 6 sextillion tons, or 6,000 billion tons. Simply put, an unimaginable amount. Recently, astronomers discovered that one of the most massive stars in the nearby cosmic neighborhood appears to have simply vanished. It was located about 70 million light-years from Earth. At such distances, individual stars are usually difficult to observe, unless they are extremely massive. This one certainly was. It shone 2.5 million times brighter than the Sun. Astronomers last observed its light in 2011, but when they examined the region more closely several years later, the star was nowhere to be found. Normally, such massive stars end their lives in an extraordinarily bright supernova explosion. In this case, however, no such event was observed, which deeply puzzled scientists. One theory suggests that the star collapsed directly into a black hole without producing a supernova, something that is possible at the final stages of a star's life, but extremely rare. CO2-141b is an exoplanet beyond our solar system. At first glance, it resembles Earth. It has oceans. Liquid evaporates into clouds, condenses, and falls back to the surface as precipitation. The difference is that instead of water, this cycle involves molten rock. The surface of this exoplanet is entirely covered by lava oceans tens of kilometers deep. During the day, temperatures on CoRo T7b, CO2-141b, rise to about 2,700 degrees Celsius. Under these conditions, magma in the oceans evaporates into the atmosphere. Extremely powerful winds, reaching speeds of more than 1.5 kilometers per second, carry these rocky vapors to the planet's night side. There, the vapor cools, becomes liquid again, and falls back as stone rain. It seems that an ordinary umbrella would be far from sufficient on such a world. There are 3 golf balls on the Moon. They were left there by astronauts during the Apollo 14 mission. Mathematical models allow for the existence of white holes, although scientists have not yet observed any in practice. If you were to encounter a white hole, it would be impossible to enter it from the outside, but you would be able to see light and matter being expelled from it. One full rotation of Earth takes 1 day, while the Sun, due to its enormous size, requires between 25 and 35 Earth days to complete a single rotation on its axis. The Moon is not a perfect sphere. Under the influence of Earth's gravity, its shape is slightly elongated and resembles an egg. Spacesuits protect astronauts from extreme temperature fluctuations during spacewalks from approximately 160 to 120 degrees Celsius. A neutron star is formed after the collapse of a supernova. Immediately after its birth, it begins to rotate at an incredible speed, about 60 revolutions per second, and in some cases, this rate can reach up to 600 revolutions per second. In 2007, astronomers detected extremely powerful and bright radio signals known as fast radio bursts. Their sources are located billions of light-years away from Earth. While in space, astronauts often notice sudden flashes of light. These occur when cosmic rays interact with the optic nerve in the eye. A walk along Pluto's equator would be roughly equivalent in distance to walking from Rome to New York City. If you were to visit the exoplanet 51 Eridani b, located 57 light-years from Earth, you would see that the planet glows. This is due to heat left over from its formation. The planet has a dull purplish color, similar to that of a dark cherry. Jupiter has the shortest day of all the planets in the solar system. It lasts only about 9 hours and 55 minutes. Because of its rapid rotation, Jupiter is slightly flattened and not a perfect sphere. Venus has more volcanoes than any other planet in the solar system, at least 1,600 of them, although most have been inactive for a long time. Mercury's surface is covered with peculiar wrinkles. As its iron core cooled, the planet's crust contracted, making the surface extremely uneven. So-called nuclear pasta, found inside neutron stars, is considered the strongest material in the universe. This neutron-based structure may be up to 10 billion times stronger than steel. Some scientists suggest that black holes may not have a traditional event horizon, the point of no return. Instead, they may possess a so-called apparent horizon, which temporarily traps matter or energy before it disappears and re-emerges in another form. Each Apollo mission required 15 spacesuits. Each of the 3 main crew members had 3 suits, 1 for training and 2 for flight plus an additional backup suit. Each member of the backup crew had 2 spacesuits, 1 for training and 1 for flight. Scientists believe that Mercury's core may still be partially molten. This could explain why the planet has a magnetic field that is about 1% as strong as Earth's. Dust storms on Mars are considered the most powerful in the entire solar system and can rage for many months. On the exoplanet Kepler-16b, located 245 light-years from Earth, not 1 but 2 suns rise above the horizon. The planet has a mass comparable to Saturn's, but a higher density. It takes an astronaut about 45 minutes to put on a spacesuit, and then roughly another hour to adapt to the new conditions. Fireballs are especially bright meteors that enter Earth's atmosphere, leaving a brilliant trail behind them. Triton, one of Neptune's moons, orbits the planet in the opposite direction of its rotation. It is the only large moon known to do so. In addition, Triton is gradually moving closer to Neptune, and scientists believe that eventually the planet's gravity will tear it apart, forming a ring around the gas giant. The dwarf planet Haumea, located in the Kuiper Belt region of icy objects surrounding the Sun, has truly unusual characteristics. It has an elongated shape, 2 moons, and an extremely short day, lasting only about 4 Earth hours. Most remarkably, Haumea is surrounded by incredibly thin rings, which likely formed as the result of an ancient collision.